Hello everyone, this is Mrs. Eisenman. Today I'm excited to take you through yet another way to solve systems of linear equations. Today we're going to talk about how to solve them algebraically by using a process called elimination. So over the last several classes we've talked about several different ways of solving linear equations, systems of linear equations. The first, of course, was graphically, graphing the two lines and looking for on the graph where those two lines intersect, that point of intersection. Then most recently we of course covered the first algebraic method, which was called substitution. Alright, so let's get started on what this elimination process is all about. Okay, so every one of you should have this in front of you. It's the steps that we're going to go through in order to solve a system of equations by elimination. So the first thing we need to do is write the system of equations so that the terms are what we call aligned. And basically that means that we need them to be in this form. ax plus by is equal to c. So we want our x terms on top of our x terms, our y's on top of our y's, our equals aligned up, and then our constants alone on the other side. Step 2 is, this is the most important step in solving by elimination. If necessary, multiply one or both equations by a constant to result in two equations that contain terms with opposite coefficients. So what does it mean to have an opposite coefficient? Well, just you can kind of put as an example here, like for example 3x and negative 3x would be considered opposite coefficients. Okay, those are opposite terms in that if I were to add them together, of course my answer would be 0. The next step is to go ahead and add to eliminate one of the variables. So if you have these opposite coefficients, then when we add them, like I said, you're going to be able to eliminate, and that's where it gets its name, that variable. Then we're going to go ahead and solve the equation that results. Substitute your answer you get into either starting equation to get the value of the other variable. Then you will have both x and y, so you can write your solution as a point of intersection, x comma y. Okay, so let's get started with some examples. The first example, you want to go ahead and copy this down unless it's been provided for you. Okay, so example 1 is 4x minus 3y is equal to 3, and 4x minus 5y is equal to 5. Alright, so the first step was to make sure that our variables are aligned. And as you look here, we can see that they are definitely aligned on top of each other. Okay, the second step was to go ahead and multiply one or both equations by a number in order to get opposite coefficients. Okay, so if you look here, this one's actually a pretty easy one to start with. Because if you look at your coefficients, in front of the x's we have coefficients of both 4s. In front of the y's we have a negative 3 and we have a negative 5. So which of those would be easier to just go ahead and make opposites? Well, definitely if you're already starting with the same absolute value of the number. In other words, these are both positive 4. If you are starting with the exact same number coefficient, it's easier to start with that one. So what we're going to do is we want to make them opposites. Well, what number can you multiply in order to change it from being positive to negative? And hopefully you're telling me you can multiply by negative 1. Now notice that the next step, or that step told us to multiply the entire equation. So this is going to be a really important step. We aren't just going to multiply the 4x by negative 1, but the entire equation. And so we have to multiply that negative 1 to all of the terms. Okay, so when I do this, I'm going to get negative 4x. Then negative 1 times negative 5y is positive 5y equals negative 5. Okay, you want to recopy over your other equation right on top of it. So 4x minus 3y is equal to 3 is my top equation. Now you can see right here that what I have created are opposite coefficients, opposite terms. Okay, the next step in this process is to add down. We are adding down. Okay, so if you are using your graphing calculator or just a regular calculator to help you with adding these, you're going to type in 4 plus negative 4. And of course, hopefully you realize that that's going to be 0x, so it's going to go away. Okay, then you're going to type in negative 3 plus 5. And so you should end up with a 2y is equal to 3 plus negative 5 is negative 2. Okay, now we have a resulting equation. 2y equals negative 2. That equation can be solved very easily by dividing both sides by 2. And so we end up with y is equal to negative 1. That is our first solution that we have. But we can't stop here. A lot of times students think once they get one answer, they think they're done. It's a huge common mistake that students make. But remember, we are solving for a point of intersection. We are solving for an x comma y. So what we have just found, of course, is the y value. Okay, we've just found our y value is negative 1. We still need to find our x. So the next step is to take our negative 1 as y, plug it into either of the original equations, and solve for the x. So I'm going to take the 4x minus 3y equals 3, the top equation, and I'm going to go ahead and substitute in my negative 1 in for the y. So I'll have 4x minus 3 times negative 1 is equal to 3. Okay, 4x. Many of us have gotten stumped on this before. You're multiplying negative 3 times negative 1. That's going to give us a positive 3 is equal to 3. Okay, a couple quick steps to solve this equation. Subtract 3 from both sides. We get 4x equals 0. Divide by 4 on both sides, and we should get x is equal to 0. So now we have our x value and our y value, so we can write our point of intersection here is 0, negative 1. Okay, our second example, again, you want to go ahead and get that copied down. Okay, it's 5x plus 6y is equal to negative 8, and 2x plus 3y is equal to negative 5. This one's just one step up in difficulty from the first one we tried. We don't have any coefficients that already are equal. We have a 5 and a 2 in front of our x's, and we have a 6 and a 3 in front of our y's. So if they're not matching or equal to start, then the next thing we want to ask is one of them a multiple of the other? In other words, can I quickly multiply 2 by a whole number to get me 5? And hopefully you'll all say, no, you can't. Can I multiply 3, though, by a whole number to give me 6? And now hopefully you'll say, oh yeah, 3 times 2 is 6. Okay, so we know we have to multiply it by 2. But let me ask you, if you multiply it by 2, that's going to make this term here a 6y. Remember, we want them to be the same number but opposites. So instead of multiplying by a 2, we're actually going to multiply by a negative 2. And remember, like I said, we multiply the entire equation by negative 2. So we'll get negative 4x minus 6y is equal to negative 2 times negative 5 is positive 10. In the top, we just copy down 5x plus 6y is equal to negative 8. We didn't have to do anything to the top equation. We can just copy it over. Okay, and now what operation are we going to do with these two equations? And hopefully you're saying you are going to add them. Okay, so 5 plus negative 4 is going to be 1x. These are going to cancel because they're opposites, is equal to negative 8 plus 10 is 2. Okay, you're going to divide by 1 on both sides, and so x is equal to 2. Remember, you are solving for a point of intersection, x comma y, and so right now we have our x part of that point of intersection. Our next job is to go ahead and substitute that 2 in for x in one of the two equations. So again, I'm just going to take my top equation, 5x plus 6y is equal to negative 8, and replace the x with a 2. So 5 times 2 plus 6y equals negative 8. Multiply that 5 times 2, gives you 10 plus 6y equals negative 8. Solve this quick two-step equation by subtracting 10 to both sides. 6y equals negative 8 minus 10 is negative 18. Divide both sides by 6, and we end up with y is equal to negative 3. So now again, we have our point of intersection here as 2, negative 3. Okay, ladies and gentlemen, we're going to try one more before you are going to try one on your own, and we'll be done for the night. Okay, the third example here, again, copy it down in your notebook nice and neatly. 4x plus 2y equals 8, and 3x plus 3y equals 9. Okay, this is definitely going to be the trickiest of any of the ones that we've done. First of all, again, look at those coefficients in front of the x's and in front of the y's. So in front of our x's, we have a 4 and we have a 3. In front of our y's, we have a 2 and we have a 3. Is there a number that we can quickly multiply by 3 to give us 4 or 4 to give us 3? And hopefully you're saying no. Is there a number that we can multiply by 2 to give us 3 or 3 to give us 2? And again, the answer is no. Okay, so then what we need to do is actually multiply both equations by different numbers. Okay, and we have some options here. We can either choose that we're going to eliminate the x's or choose to eliminate the y's. It does not matter. And so if I decide I'm going to go ahead and try to eliminate my x terms, okay, well then that would mean I'd need to have the same number in front of the x, but opposites. So let's think about it. 4 and 3. If I just multiplied the other equation by the opposite number, in other words, if I multiplied the top equation by 3 and the bottom equation by 4, what does that force to happen? Well, now, when I multiply here, 3 times 4x, I'm going to get 12x. And when I multiply 4 times 3x on the bottom, I also get 12x. Okay, but just like before, I need one of those 12x's to be positive and one to be negative. So in order to ensure that that happens, I'm going to go ahead and multiply one of my equations as a negative. So I'll just do it to the top one. Again, it doesn't matter. Okay, so I'm going to go ahead and multiply those numbers through the entire equation and write that over. So the top would end up being, like I said, negative 12x. And then it's negative 3 times 2y, which is going to be negative 6y. And then I have negative 3 times 8, which is negative 24. On the bottom, I multiply the entire equation by 4. So positive 12x plus 4 times 3y is again positive 12y is equal to 4 times 9, 36. Okay? Now, once again, I'm going to add down. So I add down, my x's are going to cancel because they're opposite terms. When I add negative 6y plus 12y, I'm going to get a positive 6y is equal to negative 24 plus 36, I should get 12. Divide both sides by 6 and get y is equal to 2. Okay. So again, that is the y coordinate of my point of intersection. Okay, I now need the x coordinate. So now I'm going to go ahead and substitute the 2 in for y in either of my equations. So again, I usually just grab the top equation and I go ahead and plug it in. So 4x plus 2 times 2 is equal to 8. 4x plus 4 is equal to 8. Subtract 4 from both sides. 4x is equal to 4. 8 minus 4 is 4. Divide by 4, and we get x is equal to 1. So our final answer here, our point of intersection, is 1, 2. It's really important to understand the connection between the different ways that we've been solving these systems of equations. I want you to realize that if I were to have solved this system of equations graphically, in other words, gotten this equation into y equals form, gotten this equation into y equals form, and graphed the lines, guess what? On the graph, those two lines would have intersected at the point 1, 2. Okay, so this is just a different way. It's called an algebraic process or an algebraic solution to solving this system of equations. Okay, lastly, we have one last question that we would like, as it says here, for you to try on your own. So I want you to copy that example down, 5x minus 2y equals 7, and x minus 3y equals negative 9. I want you to look back at the 3 examples that we have, decide which of the examples this is most like, and then go ahead and proceed to go through the steps and solve this system. The only thing I do want to give you a little bit of a hint on is, like I said, we always start by looking at our coefficients. And so here, I just want to make sure you're aware, what are your coefficients for the x terms? You clearly see a 5 here. What is this coefficient here? And hopefully you know that that is a 1x. Okay? And then your coefficients for your y's are negative 2 and negative 3. And of course, you now need to go ahead and try to multiply through by something to make opposite terms. Okay, thanks so much. Please make sure you finish this one. Mrs. Hennessy and I will be checking it tomorrow in class, and I hope you have a great night. Thanks so much.